So, Julia, you said you've already done number one, right?
Mm-hmm.
You want to walk us through that?
Sure. So we set it up in the matrix. So we have 1, 0, 3, and then the line, so they pass the line. And then row 2 is 3, 1, 2, and then 5 is after the line. And the last row is 2, 2, 1, and then after the line is 4. So
Okay.
that's how we
Let
get
me
that set up.
write all this down.
Did you get -7/3 for x, Julia?
For x, -7, no.
What'd you get?
I got 8 for x.
8 what?
8/3.
8/3.
So in the matrix, the modified or whatever it's called, augmented, right? Something like that.
Yeah.
Got 0, 1, -3, and the constant is -2, right?
The 3 is positive.
What? What'd you say?
The 3 is positive.
The 3 is positive? On the first equation?
Oh, no, just kidding. It's -3. Sorry.
Okay. 3, 1, and -2, and then the constant's 5. And 2, 2, and 1.
Yeah.
It's over here. Cool. So what did you do the matrix?
So then after you get the matrix, then you gotta get like so you got to get the first 2 numbers below 1 to equal 0, and then get that diagonal to equal 1, and all the other numbers underneath the 1 to get 0. So to get rid of the 3 in the first number of the second row, we have to multiply row 1 by 3 and then subtract it from row 2. So you get 3 minus 3 times 1, which is 0. And then 1 minus 3 times 0, which is 1. And then you get -2 minus -9, so that's 7. And then you get 5 minus 3 times -2, which is 11. And then to get rid of that first number on the third row, you multiply row 1 by 2 and then subtract it. So then you do the same thing for all numbers. So then the new matrix is, the last row is 0, 2, 7, 8.
0. The last row is?
Yeah. The last row is 0, 2, 7, 8.
So we don't do anything to the first row.
No. The first row is your constant.
And then the second row, you said we're going to multiply the second row by the first row.
Multiply row 1 by 3 and subtract that from row 2. So then it becomes like 1 times 3 is 3. So then you subtract, since the second row is 3, you subtract 3 minus 3, and that's 0. So that's how we get that 0 for the new row 2. Does that make sense?
Yes.
So then you do that for each column.
But couldn't we just multiply the first row by the second row? Because that would mean 3 times 0 is 0. 1 times 1 is 1. And -2 times -3 is 6.
No, because you get the wrong answer.
Hey.
So you take the first number and multiply it by the first row, And then whatever you get for that first row, you then subtract the first row to the second row, and that's how you get your new second row. And that's how you get the zeros as the first two numbers in those two rows.
Okay, sorry, I'm really so you multiply the first row by 3,
Uh-huh.
or negative 3, or no, it's 3, right?
Yeah. Either just go -3, then you just add it, but it's either way it works fine. That's what it does in the book anyway.
Times row 1 plus row 2 gives you the new. So on the second row, you got 0, and then -2.
No. No negatives.
I'm so confused.
How do we get rid of that last, the second 2 on the third row?
No, I don't even know.
This crossing elimination, like, it feels useless.
What?
It doesn't seem like it's
Really that helpful?
applicable to anything.
Yeah. No, it's just another long way roundabout to do math. Just annoying.
What a section 9.1?
What?
What section was the Gaussian method in?
I have no. I don't remember. So does everyone understand how I got the new second row?
What was your second row? Was it 0, 1, 7, 11?
Yes.
Yeah, we got that part. It's just kind of the last row.
So the last row is just the same thing. It's just you're multiplying it by 2 to get that 0 as the first number.
Yeah, we got zero, need 0 for the first 2 numbers though. That's the thing. Go 0, 0, 1. According to the book.
We have 1 in the first number in the first row.
Yeah.
You have the zeros in the first row, and so that's just one step to get the zeros in like the first column. So then we go a step further to get the 2 zeros in the third row. We then do it we do it the same way, where we multiply row 2 by 2 and then subtract it from row 3. So for working the first column, we work with row 1. And then to work on the second column, we work with row 2, so that we just focus on that last row and the last numbers. So before
You multiply
working,
the second row, you multiply by like -2 and add it to the third row. That'll give us that other 0.
yeah, so multiply row 2 by 2 and then subtract it from row 3. So 0 minus 0 is 0.
Can you send us your work?
I did it all on the iPad. So I had to like do it in like steps.
Crap.
So you're 0, 0, then what, -7?
Yes.
And that
Yeah, and then -14 is what I got for the last one.
So can you read all of your rows for me?
0, -3, -2.
For so on the step that me and Kim were on, my matrix is 0, 1, 0, -3, and -2.
Wait, what?
1, 0, 3, -3, sorry, and then -2 is the first row. The second row is 0, 1, 7, 11.
Oh.
And the third row is 0, 0, -7, -14. So I still have one more step to do.
That's
I
okay.
don't have
I
diagonal.
understand what I did wrong.
You divide row 3 by -7.
Yes.
Gotcha.
So -7 divided by -7 is 1. And then -14 by -7 is 2.
Okay.
So then we can kind of go back into our little equations and figure it out.
You want your coat?
Maybe, I don't know. Should I wear it?
Probably.
Hang outside though.
Well, just in case. Okay. I am dumb. I wrote it in the matrix. The first equation 0, 1, -3, -2. That's why I was like, what is going on? So can you kindly, I'm so sorry, can you kindly explain what you did one more time?
So starting from the beginning?
Yes.
Okay, so the matrix at the very beginning is
Or
1.
what do you do to the second row?
So the second row, so the first number in the second row is 3.
Yes.
So then we multiply row 1 by 3 and then subtract the 2 rows, row 1 and row 2.
So we multiply row 1 by 3,
Yes,
and then you subtract that from row 2.
yes. So you take row 2 and then subtract it by the new row 1s that you got. So it would be 3 minus 3 times 1. Then 1 minus 3 times 0. And that would be negative 2 minus 3 times negative 3.
Negative 11. Negative.
Does that make sense?
Yeah. So it's negative 11. 0, 1, negative 11.
Not negative 11, positive 11. Because you're taking 5 minus negative 2 times 3, which is negative 6. But since you're subtracting, it becomes a positive. So then it's 5 plus 6.
Is that the constant or the variable used? Negative 3s.
Constants row 2.
So your row 2 is 0, 1,
Mm-hmm.
negative. No?
Not negative, just
Okay.
positive. Because again, it's subtracting, but because it's a negative 3 in row 1, it becomes negative 9. But negative time, or a negative minus a negative is a positive. So then it's negative 2 plus 9, which is 7.
Oh, yeah. Okay. And then the constant is 11.
Oh, yes.
0, 1, 7, 11.
Yes.
Okay. I'm so sorry, guys.
No, you're good. So then you do the same thing for row 3. And you multiply row 1 by 2. And then subtract that.
That's it.
And then the last row becomes 0, 2, 7, and 8.
What do you have in the last row? What do you have?
Yeah, 0, 2, 7, constants 8.
0, 0, 7, and 8.
Oh, wait. No, well, you're still working on like multiplying by row 1. So then it's 0, 2, 7, and 8.
Okay.
So then to get the 2 zeros on row 3, you multiply row 2 by 2 and subtract it from row 3. So you're doing the same thing just with row 2.
2 by 2 and subtract it.
Yeah.
Okay.
So then row 3 becomes 0, 0, negative 7, negative 14. And then to get the last number on row 3 to equal 1 so that we get that diagonal 1, we divide by negative 7. Only row 3. So then it becomes negative 7 divided by negative 7, which is 1. And then negative 14 divided by negative 7, which is 2.
Okay.
So then there we can plug it all back into the equations. And so z equals 2. Y equals -3. And x equals 4. Did
Okay.
everyone get that?
So the x equals 4?
Yeah. Is that what you guys got?
Yeah, that's what I got.
Okay, just making sure I did my math right.
Yeah, thanks for explaining that.
Okay, no
Yeah.
problem.
Sweet. Okay, cool.
Number 2 is pretty easy.
Number 2?
Yeah. So, it would be equal to a constant k. To show that, I just wrote out the 2 matrices. I wrote out just 2 example ones. So like first matrix 2 by 2. I put 1, 2, 3, 4. And the other matrix was another 2 by 2. 5, 6, 7, 8. Then I added them together and then multiplied them by k. 6k plus 8k, or 6k, 8k, 10k, 12k.
Mm-hmm.
And then for the other way, I wrote them out and multiplied them both by k individually. So it was k, 2k, 3k, 4k, and 5k, 6k, 7k, 8k. And it came out the same. And you plug like 5 in for k, and it comes out the exact same every time.
Okay.
And then B is just one of the principles that's in the book. So if you multiply an m times n matrix with an n times p matrix, makes an MP matrix. Or an m by n and an n by p makes an m by p matrix. So the n's,
Okay.
like we talked about yesterday, were the columns, and the column of the first set and the row of the second set have to be equal.
Right. Okay.
It was the written work.
I was going to, but I don't have to. I'm still trying to write down number 1.
Okay.
Yeah, number 1 has a lot of steps.
Are you doing it, Julia? You want to do it?
Not because I can't find my notebook, so I'm not going to be able to write down all the quote.
I can do it if someone like sends me the work that we just did, because I've been like trying to write it out so I remember, but I don't have everything.
Okay.
I can
I can do it. It's fine.
Yeah, afterwards, and I can send them. I can send pictures for you, Michael.
Okay.
I can send you pictures of each step. Yeah. Okay. So are we working on 3 now?
Yeah. So we have an infinite geometric series. Let's see.
Wait, real quick. So for the answers on number 1, we have y equals -3,
Yes.
z equals 2, and x equals 4.
Yeah.
Okay. Callum, do you want to send me your work on number 2, and I can write that all down?
Yeah.
And then we'll do number 3. Well, you guys are already doing it. I wonder if there was supposed to be a part B to number 1.
There's what?
I wonder if there was supposed to be a part B to number 1.
I mean, that's what I was wondering about too, or if there's an A, but
Yeah.
yeah. I'm not going to complain.
I'm going to write a part B. 2 plus 2 equals 4. Michael. Nice.
Probably make it a little bit more complicated. And add x's and y's in that equation.
What's that?
For the part B, Curtis, you should make it a little bit more complicated and add like x's and y's or like fractions and things like that.
Yeah.
No, we should add sine and cosine and trig
Oh,
identities.
yes, there's the
No, we should.
complications right there.
No idea.
What? I don't remember this.
Try not to send it to my bishop again.
Okay, I just sent that, Curtis. Your text.
Okay, sweet. I know what I could do. I could expand on that joke Michael made about his grade.
Ha.
We could like write a word problem. Michael's grade on the last test in his math class can be represented as this equation, and then it boils down to like the sine
100.
of pi.
That'd be pretty accurate.
And you did better than either me or Callum.
Yeah, it's true.
I don't know about that.
No, it's true. Grade says it.
Callum got a 60, I got a 66, and you got a 69 or something, or a 70 something.
71, I think.
I think I broke into the negatives. I don't even know how that's possible, but I think the teacher just really needs to.
You did so bad. I'm taking away from your regular grade.
Sitting at a -4 right now, guys.
Nice.
Actually, I'm at a -A. Not an A minus, a -A.
I'm getting a Z, so I don't know.
Z. Oh man. Holy cow.
Yeah, I'm looking at the book to find kind of an example for one of those. I had it a minute ago, but just got back and find it. Okay, so for this one, A is 0.18 and R is 10 to the -1.
Yeah.
We need to put it in the form of S equals A over 1 minus R.
Hey, buddy. Hi. Oh. Yeah, not that one. Hi, buddy. Hi. Why?
It's pretty easy. You just go 1.8 divided by 1 minus 10 to the negative 1. And it's 2. That's not cool. Let's see. For 3, which isn't a fraction, but anyway, you do 2 over 1. Never mind, hold on. All right, never mind. I got 1/5.
So, Callum,
Yeah.
is this answer you sent me, is that part A and part B?
Sorry, that was only A.
Okay.
So B, it's just a principle that's in the book that says, like, if you have the matrix m by n and multiply it by n by p, you get an
M by
p matrix. So if so, what size result in matrix sisters? But m by p,
Right.
I have to explain why, but it is. So you don't have to explain why. Let's see.
Having a good day.
Number 3. I don't know if it's 0.18 divided by 1 minus 10 to the negative 1 or 10 to the negative 2.
So what are we working with here? What have you guys got so far in number 3?
So what I see in the text, so our repeating number is 18 is 1/8. And so
1/8, you said?
yeah, 1/8. So 0.18 would be the A. And we're trying to get it into the form of S equals A over 1 minus R. I'm trying to figure out if R would be 10 to the negative 1 or 10 to the negative 2.
So A1 minus R?
So A divided by 1 minus R.
Oh, okay. So our A is 1/8.
So I'm thinking that R would be 10 to the negative 2 because we're going back 2 decimal places each time. We're going back 2 numbers.
Trying to figure out what R is. Can you check it with a calculator? Is that allowed?
Allowed. I hope it's allowed because I just know, yeah, and a calculator. So I know that, like, okay, it's weird. I had a math teacher and she had us memorize like some of the infinite decimals and everything. So we have to somehow get 2 over 11. So just to make sure that I was right and I remembered right.
Yeah, we got it right then.
Did it in the calculator, and it's 2 over 11 is the
Okay.
fraction.
So R is 10 to the negative 2.
Okay.
Yeah, when I plugged that in to a calculator, that's what I got. 0.181818181818.
Bad brain fart and you think go that easy. my
What?
mind's still in the everything's really complicated state of mind. But this is all a lot more simple than I think it'd be. But yeah, so you put it into S equals or 0.18 over 1 minus 10 to the negative 2.
Yeah.
That gives you 2 over 11. Cool.
Sweet.
When did you guys want to get together to study for the final?
Maybe. How's your guys' Wednesday look?
I'm completely open.
Yeah, Wednesday morning works fine for me.
Okay.
Okay. Yeah, I could do like Wednesday. Maybe we could do like 10 till lunchtime, noon.
Like 6 a.m.
Yep.
6 a.m. to noon? Done.
Yeah, I could do like 10 a.m. to 12.
Yeah.
10 a.m. to 12 a.m. I'll just be there all day.
Actually, I got something going on. I won't be there.
Oh, at 10 a.m.?
No, from
I can tell you're messing with me now. Okay.
You're sleeping, right?
I'll be in
Yeah, I'm
dreamland.
gonna troll.
Yeah.
All right, we can sleep at the testing center. Let's see. All right, so 10 to 12. Sound good?
Yeah. Is there anything you guys wanted to go over real quick for this test today? I feel like this last few sections have been super easy, but that first little bit of this stuff took forever.
Yeah.
I don't know what section it was, but
I'm just gonna go over like on my own today, I guess, but just what's it called? The Gaussian elimination thing, because I feel like we get to one part of it and it's just like a guessing game. I'm so bad at that part.
Yeah.
Like I don't even. It's probably how it is for everyone, but.
All right.
Like I said, I feel like it's just like a waste of time to use that method, but whatever.
Yeah. But, oh well. So I think stuff that took forever was the systems of equations. That stuff took a long time, but
for sure.
Yeah, I'll go over that stuff today. But sounds good.
All right.
Cool.
Good luck, everybody.
Look outside, guys. It looks nice out.
On the test.
Yeah.
Thanks, you too. See ya.